Hi everyone and welcome back to the multiverse of 100 plus data science project series. In this video, we will talk about the DDoS attack classifications using machine learning. So first, let's see what is exactly the DDoS. So DDoS is stand for distributed denial of service. Okay, service, and simply it's called the DDoS. So it's an cyber attack on a specific server or network. See the word called denial, it means refusing some of the network traffic. We can say that network traffic, and it intent purpose of disrupting the normal operations. It basically happen in the any kind of website or any kind of web server. Okay, any kind of web server. Basically, it's basically flooding the target. Let's say target is, let's say, website with a constant flood of traffic. It's basically send some of the bad packet to the web server or the network traffic. Okay, so this is called the DDoS. So let's take one example first. So instead of taking the example, it's better we can see some kind of visual representations of the DDoS attack. So let's see. So let's assume that we have one web server. Let's say this is our web server. Here you go, here you go, and here you go. Then here we have the two computers, or you can say the user screen. So user screen, let's say this is the user number one, and this is the user number two. Okay, user number two. Let's say this is an shopping website. Let's say shopping types of website. Here you user can buy shoes or t-shirt, everything. Okay, and this is also the UI, shopping UI. So the user is sending some of the request to the server, and the server is give the access, give the access so that it can the user can also access the all of the product which one is available inside this shopping website. Okay, now let's assume that the capacity of this web server is 100. I mean, at a time, the web server can process the 100 requests. Okay, I mean from the 100 users. But what if 105 request is coming? So server is unable to process the rest of the 5 because it's the limit is exit, right? It's basically happen when you are finding any kind of results, I mean both exams in the websites, and so many device is trying to access the results at a time. So sometime the web server is crashed or we unable to reach to the server, something like that. Okay, but what if there is an attacker, there is an attacker, and the all of the packets or all of the request is coming from the one source. All of the request is coming from this one. So let's say this is attacker. Okay, is coming for or is sending the packet, some of the bad packet to this web server. Let's say it's sending here 110 packets to this web servers, and web server is unable to access it or unable to process it. Okay, so that time the website it's running inside the server, it's quite a little bit slow down. It's quite a little bit slow down. That you can also see in some kind of board exam based the websites where you basically checking for the results. Sometime our server is going to slow down. Okay, but usually the server is not getting slowed down. This is because of so many requests is basically sending to our web server. Now, in the case of DOS, in the case of DDoS, the attacker is sending some of the packet from the one source, from the one source. But one of the things that it's not called a DDoS, it's not called a DDoS, it's called a DOS attack. It's called a DOS attack because it's coming from just one source. Okay, DOS mean denial of service. It's mean refusing some of the services just because of some of the bad packet is passing and some kind of flooding at the target with some constant flood of the traffic that is coming from this attacker. So the web server also can easily handle it because it's coming from the one sources, and the web server can easily cross out this thing. Now what if we have the multiple number of source? We have the multiple number of source. So let's assume that again. So this our web server, this our web server or a network, and here is multiple number of sources. Okay, multiple number of sources or multiple number of bot. See again, multiple number of sources or the multiple number of bot. So those, let's say this is the source, and those are nothing but assume that as a bot. Okay, let's assume that as a bot. And here is our the shopping website that you can see. So it's our shopping website, and this the shopping website. Okay, let's say this is the shopping websites, and that's our web server. Okay, that's our web server. That's our web server, and those of the users is nothing but the bot. And after that you're creating here a network, and it's called a botnet. So what actually attacker do? Attacker is sending the bad packet from the different devices, and the web server is getting crashed because it's unable to process that bad packet. Okay, so how the actually attacker try to finding this kind of different sources? Maybe they're using here different kind of devices, or either they're actually hacking some of the devices, sending some of the malicious softwares, installing them, and try to access all of the devices remotely, and try to sending the request to the web servers. And once at a time, Hawaiian, it will sending here so many types of, so many amount of bad packets or request or sending the traffics, and this web server is getting crashed. It's maybe happen because some kind of personal issue or having some fun with the attackers, as well as maybe the attacker is not going to like the company. Okay, sometimes so many things actually maybe happens. Now in this video you are going to see that how can you creating here an classifier using machine learning, so that you can also classify the DDoS attack. So now let's see the data pipeline, that how can you actually basically resolve those problems. Okay, so first let's see the data pipeline. So let's say data pipeline. So first you're going to collect the data, collect data. So you're going to collect the data from the Kaggle basically, and then after there, number two, we are going to process the data. Let's say process the data. So in the processing part, it maybe have the feature extractions. So it maybe have the feature extraction. Okay, it should be extraction, or it maybe have the feature formatting. Let's say feature formatting. Then we can also having some kind of null values, so that you can also handle those null values, or you can see the missing values. Then in the number three, we can do some kind of data analysis. Let's say analysis. So we can do the data explorations. So let's say data exploration, or you can say the data exploring. And you can also do the feature distributions. Okay, because in our data we have the 79 columns, so it also do some kind of features distribution if it is needed. Then after that, we are going to do the data splitting. Okay, so let's say data is splitting. So how you actually creating here any kind of machine learning models? So you need to creating here the two after the data. One is called the training, another one is called the testing. Okay, because using training you basically train your machine learning models, and using testing data you basically testing the performance of your machine learning models. So in generally we basically taking the 80% of the training data and 20% for the testing data. You can take 70%, or you can also take in the 30%, it's up to you. Okay, then after that we are going to training the model. So let's say train a machine learning model, because this is a raw data itself. And here you can also using here the the neural network itself as well. I mean, the multi-layer persona, we can use them because it's available inside the scikit-learn as well. Now, after that, you're going to see that how can we evaluate the model. Okay, so we can test it out in the new data, or you can say the unseen data. I mean, the 20% data that you can see. So you can collecting here the accuracy, the F1 score, the precision, or the recall. Okay, everything. Okay, and after that, we are going to perform the classification on the real data. Okay, real data. So this is our data pipeline, that how can you actually basically solving the problems. Okay, now let's see the data first and how can you access it, and after that you're going to explaining all the code line by line. Okay, well, so in order to do the DDoS attack classifications, we're going to using here a dataset called CICIDS 2017 dataset from Kaggle. So this is a dataset. You can also access this dataset from here as well. So this is the link that you can see. Here you can easily access these actual data sets, which is a quick big data sets. You can see it's nothing but 11.0 GB. So it having it actually classify this data into some different days: Monday, Tuesday, Wednesday, Thursday, and Friday. They're basically using here some kind of data sources. Here they're basically collecting here all the data. So again, using here a small version of the data from the Kaggle just for the demonstration purpose, and you're going to using this one. So if I go down, then you can see we have the data explorer sections where you can easily access the data. So if I view more, click on view more, then you can see how many column or how many features it have in the data sets. As well as you can see the normal and attack activity details of each files. So you're basically doing the DDoS attack classifications. So it's better we can taking here this Friday working hour afternoon DDoS pcap iscx.csv, because it's also have this DDoS attack class. So what you can do, we simply going to collecting these ones. So the data set in here, the data explorer sections. So you're going to selecting here this one, Friday working hour afternoon DDoS, the pcap iscx.csv, and I can easily click on here and click on downloads. So let's click on download. All right, so we got one G file after downloading it from the Kaggles, and I started and renamed the file name as a dataset.csv. Now we can start our coding part. Now let's explaining out the code line by line. So first what I can do, we are going to importing here some of the important library. So first we import here the pandas as PD. So using pandas, we basically load the dataset from the directory. Then you also import here the numpy as NP so that you can also do some kind of matrix multiplications or any kind of matrix operations. Then you also import here the matplotlib.pyplot as PLT. It's basically used for the visualizations. Same thing for the seabars. And you also import here the CSV so that you can also do some kind of operations in the CSV file. And after that, we are going to import here the train, test, and split from the scikit-learn.model selections. So using these functions, we can divide our data set for training and the testings. And after that, we import here the standard scalar from scikit-learn.preprocessing. So using this standard scalar, we basically normalize the data in some kind of range. And after that, you also import here some of the machine learning algorithm like random forest, the logistic regressions, the SBC, and the MLP classifiers. So the random forest classifier is basically nothing but one kind of ensemble technique because it's ensembling the decision tree. So you're going to import it from sklearn.ensemble, import here the random forest classifiers. Then we are going to access it from the linear model. So you can see sklearn.linear model, we import here the logistic regressions, and from the SBM, I mean support vector machines, we import here this support vector classifier because this is an classification text. And after that, you can import from neural network, scikit-learn.neural network. We import here this MLP classifier, also stand for multi-layer percentron classifiers. Okay, and after that, you also import here some of the model evaluation matrix so that you can plot it. So from scikit-learn.matrix, we import here the accuracy score, the F1 score, the precision score, recall, RSC curve, AOC, and the confusion matrix. And then you're going to import some of the matrix again, the RSC curve, the AOC. Yep, it's maybe double time we imported. It's not needed at all. You can remove it because you only import here this ROC curve and the AOC. That's my bad. Then you also import here this label binaries so that you can also binarize each one because we have just two classes. They also imported the iter tools from iter tools. We also imported the cycles. Okay. So now let's try to use the shift enter, or you can clicking this button for running these shells. Okay. And now after that, I'm going to load in this data set. So let's say df is equal to pd dot read underscore csv. CSV means comma separated below. Now let's do the data pre-processing. So let's see the data first. Okay. So this is our data. You can see some kind of sample. So you can see the 5 rows and 79 columns. I mean, it has the 79 features. Okay. So to start from the destination port, the flow durations, the total FWT packets, it having so many of them, and some of the columns is it's nothing but what it's called, it's not missing actually, it's collapsed. Okay, so you can also see the important column, or you can say features, that's called the labels, because this is a classification stuff, so that's why the label is nothing but a target class. Okay, and after that you can see the information in the data, that how it look like, how many integers it have, how many it have the objects, or how many float. Okay, so you see that floating point number is nothing but 24, sorry, and 54 number is nothing but in 64, and it's having one object column, so which one is nothing but the label itself. So it is nothing but one categorical column, so you need to also make it in the numericals. So after that you can see that is there any non value or not. Okay, or is there any missing value. Okay, let's try to first what I can do. We simply going to strip it. I mean, why strip? Basically, we are going to removing the space before the column names. Okay, so in the column name, it maybe have some kind of spaces that you can see. It maybe have some spaces that you can see on here. Okay, but in here total, you don't have any kind this kind of spaces. So it's just going to removing the spaces before the column names. So because it's maybe happen, is the thing in which is coming under this data pre-processing. Okay, so what I can do, you can also show this out. Now let's say df dot head. So now you can see destination port. So you can also printing this out. Okay, you can also printing this out. You can also printing like that. Let's say df dot columns. Okay, let's say columns, columns. Now you can see other column name without any kind of a space, because we're running it on our data frame and try to removing all of the spaces before the column names that you can see. Okay, now let's checking the unique value in the label, because this is our target columns. So that you can see it's nothing but have the benzene and beninge. Okay, okay, beninge and the DOS attack. Okay, okay, this is the attack. Let's say this is the normal. Okay, now you can see that the plot of the missing value, it's better we can see, go on here, edit, and we can delete all of the cell output. Okay, so clear all cell, clear output of all cell. Okay, I just remove all of the output. Okay, now let's run it from beginning. Okay, that you can see it's running from 9, 10, 11. Okay, now it's cool. So you can see the columns. Now we are going to see how many unique target we have. We have two things. Let's say this is the normal and this is the DDoS attack. Okay. Now let's see how many missing value it have. Okay. Because we cannot see the missing value yet. Now let's see is there any missing value or not. So that's why I create here a methods called float the missing value, which one is taking and data frame itself. And then you're going to using here this data frame dot is null dot sum. You can also run it in here. So let's say df dot is null. Okay, let's say is null dot sum. So you don't see anything else because it has the 79 column. So it's quite hard to see it. So it's better we can floating this out. Then I use here plt dot figure, and here you need to assign here the fixed size. So this is the fixed size, and after that I'm going to show here and the bar plot. Okay, missing values dot plot, because we're creating here a variable for the missing values, and then give it here x level, y level, and title in the show. And after that you're going to calling this missing plot missing values. Okay, so now you can see this is the missing value which one is coming from this flow bytes. Okay, flow byte as that you can see, flow byte as maybe here you go, flow byte as that you can see it having some kind of missing value that you can see. So 2257 and 400, you can see the some kind of missing value it's here. Okay, so you need to removing all of the missing value from here. So we can directly dropping this one. Okay, I mean we directly dropping the null value from here. Okay, so what you can do, here you go, and you can directly drop them. Okay, let's try to drop them. Okay, we just drop the value from here. Now if I checking this one, let's say new df. Okay, you can using here this float. Okay, float missing value, and you can passing here the new df. Okay, because I just creating here a variable called new df. Now you can see this. Okay, now you can see you don't have any missing value yet. Okay, cool. Now you can also plotting this out, that you can see you can also plotting this out. Is there any the nan value or not? So data after removing the nan values, you can see it don't have any nan values. Okay, 79 79's column, it don't have a nan value because you can see the zero. Okay, if it is coming something, that is mean it may be this kind of non values. Okay, but it don't have yet. And also you see using here this float missing value function in order to seeing the float, see the bar float. Okay, that's cool. Now we are going to also checking this out, the non values, if it is have, because in our data it maybe have some kind of spaces, or some kind of value like 0.00. Okay, I just make it, I mean in our pandas I just set it as a use einf as n, so that it can it basically treating this enf as a nan. If they have the 0.0 or the string nans, or like that any kind of value it have, it will taking as the nan value. Okay, because in removing that it may be having some kind of nan value others, so you are checking those nan value. Okay, now if I printing this nan value, or you can say the null values, then you can see don't have any kind of non values. Okay, if I say that unique may be not happening in this case, because this is an variable itself. Okay, it's not be happen, but I don't see any kind of non-bills. Okay, now from this new df, I need to checking here, is there any data type which is consisting the objects, because if we have the categorical value, we need to also convert them to the numericals. And we just see that we just have the one object columns. Okay, I mean this is nothing but the targets. So what I can do is simply mapping them these labels, this the attached to the zero, sorry, normal to the zero, and the details attached to the ones. Okay, that's it. So now it is converted. We can directly do one hist plot. So let's say plt.hist, and you get using here this new df, and here you have the labels, and you give here some kind of beans, and you also give here the colors, and then you have the x t, the x level, y level, and you're simply going to showing this out. Okay, simple as it is. So you can see this is for the normal cases, and this is for the DDoS attack cases. Okay, so you're going to plot it based on the labels. Okay, how many labels have the normal, how many labels it have the DDoS, and you see that the data set is not the imbalance that we see. Okay, so we don't need to handle this out, and we see that the data set is seems like the balanced data sets. Okay, well, so I'm back again because of electricity is gone. So now we're going to exploring here our data. So for that, I'm going to using here this df.describe method in order to describe our data set in details. So it have the count, it have the mean, the standard deviations, the minimum, 25%, 50%, and 75% percentile, as well as the maximum value that you can see. Okay. Then after that, you're going to plot the distribution of the features. Okay, so we already creating here a data frame that's called a new df. So here we actually converting our data types objects into the numerical format. Okay, now we can easily plot the distribution of that. Now let's shift enter. You have to plotting this out, that you can see the different kinds of distribution plot that you can see. It will generating all of them because it has 79 columns. Well, it executed successfully. You can go and check out everything from here. Now what I can do is simply going to splitting the data into training and the testing for the machine learning models. So what you can do, you're going to first dropping here the labels, because labels is nothing but our the target column itself. So which one is go inside this y. So taking here the new df dot df from new df, you're taking the labels, and the except the label, you're going to taking all of the columns in the x. And after that, you're going to calling here these methods called train, test, and split. And here you're going to passing here the x and y. Then you give it to the test size at 30. So you can also give it to here 20. It's up to you. Then also give it here random state 42, so that it not changes it every times. Then x train, x test, y train, and y test. Okay. Now let's try to running this out, and we can also check the shape of the data sets. You can see it had the 78 columns because it's nothing but our x data, and you can see the x train and the x test data. Okay, so now you're going to using here this random forest classifier, as well as we also imported it here, that you can see in here, the random forest classifier. So we just directly using this one and creating instance of the random forest classifier. So here you go, you can see. So we using here this random forest classifiers and passing here some of the default parameters, I mean number of estimators, and the random state. It's called the hyperparameters. And then you're going to making this model name as rf underscore models, and simply feed it our training data. And then we also do the predict method in order to predicting it to our texting data. So that's it. Okay, it will fitting this out. We may have some kind of errors maybe. So it says that input x content infinite or value to large for d type float 32. So what we can do, actually we can convert the x into the sum of the floating point number, or we can directly do it, because in some kind of cases that you can see in our data, it's having some kind of floating point number that you can see in this data. If I see this one, okay, you can see some kind of data is nothing but the floating point number, and some of the data is nothing but the integer formats. So how can we actually basically divide the data into dependent and independent features? So it's better you can also convert it into the floating float 32, because you can see it has the float 64, float 64. Some of the numbers are floating and some of the number are the integers. So we can also convert them into the numpy array in the form of the float 32. So what you can do, basically we can convert it. Okay, you can convert it, and after that we can simply go into processing here this new df. So I can taking here another shell on here. So here you can basically convert this np dot array, let's say np dot array, and here you can passing here our new df itself. And then you can convert this s type is equal to np dot float 64. Okay, and after that you can also converting here our labels itself. So let's say np dot array, then you can using here this new df, and then you can use it here this label itself. Okay, like that. Okay, so let's say label. Okay, we can convert them the new df as well as this new df. So you can give it here any kind of variable. Let's say x1, and let's give it to here the y. So it's nothing but for converting into the numpy array. You can easily use these ones, and after that you can using here these things. Okay, same thing you may get the errors. The input x content infinite or a value to large for d type float 32. Okay, so I think so I need to changing this test size, because it's not working at all, because the test size the is quite big, it unable to process. Let's give it to here the 70%. I think it will work. Okay, let's see what the error actually basically. Okay, sorry for my bad, I just missing here one equal sign, I just write it right leg, that's why we got this kind of error. So it may be happen. So let's run it right out, then you can see it will execute it successfully. Okay, that you can see the rf models. Now it will taking few seconds to training the models, and then you can also decrease the size of the test size. I just give it here 0.20, I mean 20% of the testing data. And after that you need to checking here the feature importance, because it has the 79 features. Okay, 79 features is quite big number of features, so you can also selecting here some of the features from here using here this random forest classifiers. So you're going to using here this RF model, that you can see RF model dot feature importance, and then you store it inside one importance. So after that you're going to taking using here a range function and taking the length of the importance, and then you're going to we are going to show the indices number in the descending order. Okay, that you can see you're going to using here a lambda methods. So importance of I, because this is a list itself, and then you're going to making this reverse is equal to false, so that it will reverse them. Okay, and after that you're going to creating here features names and list comprehension. Here you're going to show all of the features. Okay, so we have the 79 features except the with the target columns. Okay, the labels. So you can printing it out it here, and then after that you're going to creating here a figure size, and you're going to using here this bird age, and give here the range of the extent dot shape of a one. So it will give the how many a column it have. Then you also access it in the case of indices that we shorten this out, and then you have the features number and the importance and the features importance. So if you're running this out, that you can see the feature number 6, the feature number 66. Okay, because it have the 79 features. So in the full data set, the feature number 6 have the higher intensity that you can see. And after that, you have the feature number 66, the feature number 63, feature number 53, feature number 62. It have the higher intensity. Okay, that you can see. So you can also collect here some of the features from there, to predicting this out. Okay, and you can drop some of the features from here because you don't have any feature importance. Okay, this is also called the features engineering part. You can using this one to drop some features from here. Okay, so it's your job to do that, so I am not going to do it here. Now I can also plotting the estimator plot, I mean the decision tree plot, because we know that using in the case of random forest, they're actually using here the decision tree internally. So we can also plotting this out. So you can using here this from sklearn.tree, you can import the plot tree, and then you can using this RF model estimators, use the zeroth index, then you can figuring this out, I mean period figures, and then you can using here this plot tree functions, or you can passing in these two methods and field and the rounded. Okay, so you can see it's look like the tree that you can see same like as the decision tree classifier, because we know that after joining all of the decision tree, the random forest is coming up, and we're taking here the average value from all of the decision tree. Okay, and random forest is created. Now let's try to do the model evaluation. So you can also apply here the SBC, or you can also apply here the logistic regressions. Okay, you can evaluate it. Okay. Now first, let's see how can we actually evaluate the models. So we basically plotting here a confusion matrix. So in the confusion matrix, you need to pass in here the y true and the y predictions. I mean the true value and the predicted value, and classes and the title as well. So you're going to using here this confusion matrix that you already imported, and you're passing here this y true and the y predictions. Okay, and you have the CM confusion matrix, and you're going to simply going to using here this sns.heatmap, and here you're going to passing here our confusion matrix that is generated by these functions, and attach equal to true, and use here FMT, the CMAP, the X level and the YT level. Okay, in the x-axis, the levels of the x-axis and the level for the y-axis. Then you also have the titles, and the x level is predicted and y level is true, and simply continue showing this out. Okay, so this is a function. So how are you passing here the y true and the y prediction below, so it will generating here a confusion matrix for your machine learning models. So you're going to calculate here the accuracy, the F1 score, the precisions, and the recall score, and you can simply going to printing this out. Okay, that you can see simple thing. So accuracy is 0.99 and F1 score is 0.99, and precision is 1.0, and recall is 0.998. Now you can simply continue plotting this out. Let's plotting this out, that you can see how many true positive and true negative value that is predicted, that you can see in the confusion matrix. Okay, so I'm not going to discuss this in details, because you know that what is the confusion matrix and how can you calculate them. Okay, and from this confusion matrix you can also calculate here the accuracy, the F1 score, precision, and the recalls. Cool. Now you can using the random forest regress, not random forest actually, logistic regressions, and then you're going to simply using here this LR model as an instance, and you passing here the X train and the Y train, same thing, and also same thing for the logistic regression, that you can see the same code. You can calculate here the accuracy, the FNS score, precision, recall, and everything you can show on here. Okay, And then you can simply going to plotting this confusion matrix. So you can see here in the case of logistic equations, it will do some kind of misclassification that you can see. Okay. Now after that, you can also using here the neural network. I mean that is available inside the scikit-learn. Otherwise, you can also implement by your own. I mean the ANN using the TensorFlow or Keras. Okay, as well as you can also using here the PyTorch modules. So you can see we actually using here this MLP classifier that you already imported, and you passing here the hidden layer state of the tens and the max iteration of the 10 and random state as the 42. Then using his NN model.feed and we passing here X and Y trend as well as the predictions that you can see. Okay. Now we can simply go into same thing. We can evaluate the model. Same thing we do in the logistic regressions as well as the random forest classifiers. Okay, that you can see. So you can see here the accuracy is 0.97, F1 score is 0.9784, and precision is 0.9408. And then after that, you can plotting this out that you can see. So it also does some kind of misclassifications. Okay, that you can see on here. Now you can also do the model comparisons. You can do one plot in terms of accuracy, but it's better you can compare the model in terms of the ROC curve. Okay, so in the ROC curve, we passing here the y test and the RF probability that is coming from this RF model, the LR model, and the NN models. And then you can simply going to calculate these RF pairs, these RFT pairs, okay, through positive, false positive. Okay, and then you're going to passing here all the value to the AOC curve as well, that you can see same thing for these the RF, the AOC, and the neural networks. And after that, you're going to creating here a PLT that plot in order to show all of the values. Okay, and then here you're going to passing here this our RFC, okay, RFC AOC curve values. So simple, don't worry about this code. You can get this code in the description. You can easily grab the code from here, okay, in a GitHub link. So that you can see this is our random classified AOC. I mean in the middles, it's nothing but the 50%. So above the 50% is considering as a good accuracies. So that you can see it's if I see the random forest, it's quite low like the overfitting problem because the accuracy AOC value is nothing but 1.00. Okay, that you can see. But it seems like the logistic regression is 0.98 that you can see this one, the blue one. It's also good, not bad at all. The neural network is also good, but in some kind of cases it's some kind of cases it unable to predict the DOS attack correctly, that you can see in the confusion matrix. But in case of the random forest confusion matrix, we can see some kind of overfitting problem, but it's not at all uh, okay. So you can also testing it here with some of the real data, because in our data set it have the for 79 columns. So it's I'm unable to creating here application for that, for the 79 columns. I need to put all the values line by lines. So it's your job to do on prediction tasks. Okay, you can do it. Okay, so that's it for today. Now I hope you enjoy this full tutorial, and make sure to subscribe our channels and share with your friends so that you will notify when the new video is coming up. Okay, so thank you and bye bye.